Hey, 8th grade friends. Today we are going to be looking at equations and graphs. You can find this in your book on pages 191 through 192, and you'll be doing the assignment on pages 193 and 194. So first of all, we're going to kind of fill in some notes here. And a lot of this you may remember from the last couple of days that we've been working with proportional and non-proportional relationships. But here on page 191 at the top, it says, to write an equation, we need two main pieces of information. We need the slope, or we call it or refer to it as m in the equation. We need the y-intercept, or the b in the equation. If the graph is proportional, we know the equation will be written in the form y equals mx. However, if the graph is non-proportional, the equation will be written in the form y equals mx plus b. And down below, and if you remember, in a graph of a horizontal line, the y value is constant. So that's what comes at the end of the equation, or without a variable attached to it. Therefore, equations of horizontal lines will always begin with y equals. In a graph of a vertical line, the x value is constant. Therefore, equations of vertical lines will always begin with x equals. All right. Down below on page 191, it asks us to find the slope, y-intercept, and equation for each graph below. Now, if I look at the equation, remember you can choose any 2 points on the line. Right here, it crosses the y-axis is the 4. And it looks like right here we have two points that we can figure out the slope. So if we look at that, we have 2 and 2. Rise over run is 2 over 2, which simplifies to 1. So our slope is 1. Our y-intercept is, if we look where it crosses again, I'm going to kind of show that right here, crosses at the 4, so our y-intercept is 4. So our equation is, well, y is equal to, remember our slope comes in front of our x value, but it's just 1, so 1 times x is x plus 4. Is the graph proportional? Well, we can see right here that it crosses at the 4, so it does not cross at the origin, so we know that it is not proportional. Okay, moving right along to the next problem on number 2. Okay, so on problem number 2, we're going to first of all find the slope. And again, we'll kind of, maybe I'll use the yellow this time. Choosing 2 points on the line, we could choose a point here where it crosses the y-axis and another point here, and look at rise. So it looks like we go from a -4 to a -8, so that's a -4. Rise over, run, 2, 4, 6, 6, -4, 6, but that will simplify to a -2/3. Okay. Our y-intercept, of course, is where it crosses the y-axis. So if we look where it crosses, it's at a -4. So our y-intercept is a -4. So if you remember our equation, y equals, look at our slope, -2/3 x minus 4. And is our graph proportional? And we know again, because it doesn't cross at the origin, it is not. So it is not proportional. Okay, if you'll turn to page 192, we're going to look at that graph. And if you remember, a few weeks ago, we talked about the different kinds of slopes. And we know that this is a horizontal slope. And because it has no slope, well, we just refer to that as having a 0 slope. The y-intercept, it crosses, if you'll notice, right here on the y-axis at the +4. So our y-intercept is 4. And our equation, since it has no slope, or a 0 slope, 0 times x is 0, so we're going to have y is just equal to 4. And is the graph proportional? Well, it is not proportional, right? Okay, looking at the next one on number 4, if you remember our vertical slopes, straight up and down slopes, those are undefined. In the y-intercept, well, that makes sense why it's undefined. It has no y-intercept, right? So we would just put there is no y-intercept. And the equation, if we look at where it is on the x-axis, it's at the -6. So x is equal to a -6. And is the graph proportional? No. Okay, on problem number 5, we're just asked to look at the graph and ask which of the following situations could be modeled by the graph below. Let's just kind of walk through each of these scenarios and see if we can eliminate them as we go. It says Elena has $100 in her bank account. I'm just going to look at that piece. Well, here I show 100. It starts out at 100. Every 3 days she saves another 10 and adds it to her account. Well, if I'm looking at that, if I'm adding to my account, shouldn't it go up? And it's not showing that it's going up or increasing in value. So I'm going to eliminate that as my choice. Look at the next one. Hunter weighs 100 pounds and his goal is to gain weight for football. He gains about 10 pounds every week, 3 weeks. Well, this is showing that he's going down in this case, so that can't be right. So again, we can eliminate that choice. And let's just look at the last one. Dawn's pond is 100 meters deep, so 100 meters, but her city hasn't received much rain. As a result, the pond level decreases by 10 meters every day. So look, every 3 days, excuse me. So if we look at that, 10 meters, well, here's 100 meters up here. So after 1 day, or excuse me, 3 days, we look over here, it decreases by 10, and we go from 100 to 90. So that would show an accurate representation of the scenario on letter C. All right, so on the last problem, I'm going to kind of leave that to you to create your own real-world situation that could be modeled by the graph at the right. So just pay attention to your slope, what's happening along the x and y axes, and come up and be creative with your own example. Good luck to you on pages 193 and 194.